All right, so I have the Trinity Slot Machine. I don't know why they named it Slot Machine. Somebody thought it was cool, or maybe I'm just taking a gamble with this motor. I have no idea. No, I'm kidding. I mean, Trinity makes really good motors. When you get the motor, it does come with a sensor wire, there's a piece of film that covers it, and then your little safety warning paper. This is by far, I would say, the best packed motor. This is very nice packaging. Now the Fantom motors, they're not too bad. The box is a lot smaller, so there's less material there protecting the motor. This is what it looks like. Now, a nice thing about Fantom, though, is they do give you a receipt for the analyzation of the motor. Now, I did compare it. I pretty much got the same results. Hobbywing, on the other hand, is, you get this plastic. It's not bad. It works. To be honest, you really don't need much more. But I am going to be talking about this. So what I'm going to do is I'm going to take the Xfactor and I'm going to take the slot machine. I'm going to test this, and then I'm going to remove the rotor and I'm going to place the rotor in the Xfactor. And the reason why is I want to use the same rotor for the test. I don't want to compare these two. So I'm trying to eliminate variables. So I do have this 25.5. Now I went ahead and tint the tabs. So both of these are tinned. The Hobbywing, there are some differences. Now, I've put these through the analyzers. Now, these are the V4s. They don't make a 25.5, but if you were to buy the V3s, they do have a 25.5, and dimensions are pretty much the same. So if we look at this one, 35 right here in the laminations, that's really what I want to focus on. So 35.8, let's call it. Why? Because if you look at the laminations versus this one's thinner. So this is a 34.4. So it's quite a bit thinner, and it's because of the way it's designed. Now, the Xfactor has these little extra pieces of aluminum. This one does not. So why did they do this? Maybe just to save a little bit of weight. It's really not that significant. But maybe a nice thing will be that the air, so if you have a fan, it'll hit the laminations directly. Maybe it'll dissipate heat a little better. I'm not really sure. As opposed to, say, this one, or the Hobbywing that has the larger laminations and therefore more surface area. But one of the things that is pretty nice, to be honest, is the end bell. So the end bell is much nicer. They went a little smaller, but we'll see. So I'm going to go ahead and get to testing this motor. All right, so I am going to speed through the test here, but you can pause the camera at any point. I mean, you could also hit the little slow down, and it'll slow it down. But the numbers are really the important things. So some of the tests that I'm going to do is I'm just going to check the KVs like I usually do on the motors. Unfortunately, as of the time of this video, making the video, I have not gotten my motor analyzer yet. A buddy of mine's building one up. He just hasn't had a chance to finish it off. But hopefully I have one soon. Then I can test some of the Hobbywing rotors, for example, and give you the Gauss. But these are the KVs on this. Now, something else that I did is, this is the brand new motor with brand new rotor everything. I'm going to remove the rotor off of this motor and put it into an old can, an old Xfactor can, and then just run it. Then I'm going to take the old rotor from that motor, put it in this one, and see what the difference is. And I'm doing this out of curiosity. Now, I have to make a note that because the other can is not brand new, it's not the best way of comparing the two, but I do have the data of that motor when it was brand new, and I did the same exact test, so I will be giving you those numbers so we can actually compare the new stuff. So I'll give you that toward the end. Now, as far as the build for this motor, I do like the can. It looks nice. I do not like the timing end bell. And the reason why is the little notches that were milled into it make it a little harder to line up the lines. The Trinity Xfactor has lines every 5 degrees. This one has lines every 10, but then it has those rounded, machined, crescent milling sections that make it difficult to line up the lines for the timing. But it's not a big deal. Now the timing on the slot machine, the end bell is a lot smoother, so you can actually loosen the 3 screws in the back and move it by hand, no problem. On the Xfactor, most of the time I have to use pliers. It's just more of a challenge to do that. Something that I do have to note is the weight. They weigh the same, so there's nothing really as far as the weight. The Xfactor weighs at approximately 145 grams, and the slot machine weighs at 145 grams. So there's really no savings in the design, it's just a difference in design. Now, Trinity does make some bold claims about it being more efficient and other things. I'm going to show you the table, and then you can come to a conclusion based on that. But there is one feature other than the end bell that I do really like about the slot machine, and that's the tabs where the wire goes. So the tabs where the wire goes, those tabs, they now bend at a 90 degree, and they are now flat, and there's more surface area to solder the wires, which I think is great compared to the old crescent shape. And here's the data. Now I'm going to start with the Trinity Xfactor. Now this is when this motor was brand new. This is the regular Xfactor. Now, you can ignore the first one. This was at 5 degrees timing. Now, one of the things about the Xfactor is the lines for the timing. Those things are usually way off. They were way off here. Versus the slot machine, they're more accurate. So they did improve that. So before I continue talking about the data, things I did not like about the Xfactor that I like about the slot machine is the end bell. It's kind of hard to move without using pliers. This one, it's a lot smoother. You can use your fingers and you can move that end bell. Still not as smooth as a hobby wing, but a lot smoother. The other thing, they use the same rotors. The other thing is the tabs. I don't like that crescent shape tabs on this one. This one has tabs that come out of the end bell and then they go forward, so you can have a nice flat concave surface to place the wire and solder the wire. So those are the two things. Now, one thing I do not like about the slot machine is the timing, the little marks on there. They decided to machine these little crescent shapes onto right where the timing marks are, which I think is very stupid, to be honest. And it just makes it a little more challenging to get the line correct, versus this one doesn't have that issue, although they're not accurate. So those are things to consider. Now, if we compare these, so this is what we have. So on this one over here, if we look at just timing, this was set at 35, it read 32. This is the spread. I don't really like the spread. This one had a bit nicer, but it happens. Some motors have a little more spread than others. Not two motors are exactly the same, I guess. But we are looking at 1713 kVs at this 32 timing. This is 33, 1761. They're very close. They're almost identical, except for, if you look at this, 33, 1761, 32, 1713. This one is pulling 1.2 amps. This one's pulling 1.4. Now, that 0.2 difference could be the reason for the kV difference. Because if we look at this kV, this is about the same. So if we look at this one's pulling 1.5, and that's about the same kV difference, except for we are at 38 degrees. So this is 5 degrees more. So this one is going to pull the same amount of kVs at greater timing, but the amp is the same. So amperage is the same, it's just greater timing to get that same amount of kVs. Now, I do not have an actual 2000, but I do have a 2092 and a 2102. These are close enough. So to achieve this kV, this one's pulling 5 amps. So the sweet spot for this one's going to be between 53 and 55 degrees of timing. But this is at 53, and we are at 2102, and this is at 48. So again, 5 degrees more to get the same kVs. But now, if you look at the amps, this one's pulling less amps, this one's pulling more amps. So that's something to consider. Now, is this a good thing? Is this a bad thing? Well, if I had to take a guess, this might actually be good. And the reason why, based on the claims, there's a relationship between volts, resistance, and amps. So voltage is resistance times amperage. So assuming they're pulling the same volts, which I mean here this is just because of the battery, the kVs wouldn't change. Through the motor, that means if it's managing to pull more amps, there's probably less resistance, assuming the voltage is the same. So maybe it's true, maybe not. Now, we'll be testing this motor for an entire race series. It's 6 races that are coming up. As soon as this video is published, it'll be, I think it's the week after. I have to check the calendar. So in about 3 months from publishing this video, I should have an update. Actually, after the first race, I should probably have an update. My friend's keeping his car the way it was. I know how it was doing before. We actually had a great series, the previous series. It was amazing. We actually tied for points. It went to laps, and then I just happened to have 2 more laps overall in the series, so took that one. He beat me in Sportsman, though, but we don't talk about that. No, I'm kidding. But back to this. So if we look at 50, so now I will compare timing. So if we look at 50 degrees of timing, here's the spread: 51, 46, 52. We're looking at 1944, so 1944 pulling 3.4 amps. Versus this 50 degrees of timing, we have a 53, so that's 2 more here. 47, that's 1 degree more. And 49. Was I reading the correct ones? Oh, okay, yes, I was, and this is 3 less. So it averages out to 50 and 50. So let me go ahead and highlight this, and then I'll just use the mouse over here. So here we go, 50, so +2, +1, -3 gives us an average of 50. If we look at the kVs with the Xfactor, we're looking at 2,331 versus 1944. But again, we're looking at 5.7 amps versus 3.4. So this one pulls more amps at less timing. Let's see what else. So now if we do amperage instead, this is a 3.4, this is a 3.4, and if I go down the opposite way, this one is pulling 2026 versus the 1944. They're pretty close, so they're pulling similar kVs. They're not quite 100 off, but they're pulling the same amps, similar kVs. And if we look at the timing, 46, so 4 degrees less. So the regular Xfactor will usually, based on this, pull more kVs because it's pulling more amperage at less timing. That's really the way it goes. So 4 to 5 degrees timing, that's what's giving you the kVs. So the Xfactor Slot Machine, you really have to turn the timing up. Which is interesting. The reason why I say that is, if we go back here, you probably remember this from an old video when I was comparing the Team Powers Actinium V3 versus the Xfactor. This is the same exact data as this right here. But if we go up here and we compare this 43 to that 44, one of the things that we notice is less amps, less kVs. The Xfactor Trinity was pulling at the same amount of timing. It was pulling a little more amps, doing a little more kVs. If we look at the blue, 5.7 amps, 5.7 amps on top, more kVs at about the same degrees. And if we base it on kVs, for example, this, if we look at the white line, 2080 versus 2092, this one did 2080 at 6.2 amps. In order to achieve this, it drew a lot more amperage, and we're looking at 52 kVs versus 48. So this one over here had to be at higher timing and pulled more amps. This one was lower timing, less amps. This motor, when I did the test, if you've watched the video, it was the top speed for both of them was the same, but the acceleration, Xfactor accelerate much faster. So I am wondering if with the change that they did here, if maybe the slot machine will do the same thing. Maybe, maybe not, because the other one, it was higher timing, higher amperage. Here, we're seeing something different. We're seeing higher timing, lower amperage. Let me just double check that information, because I just made that statement. So 50 degrees, 3.4, 50 degrees, 5, yes. So this one, for the same timing, less amperage. It does have less kV, though, and it is a significant amount. So this one's sort of the opposite. It's definitely a different design. So we'll see how this one does. And these are the numbers really that I'm comparing, because they are the closest one right here. kV's not that far off. Amperage is the same, but we're looking at a timing difference. So higher timing, we have less kV, same amps. Versus over here, we would have, let's see, right here, more kV, sorry, less kV on this one, more kV on the Xfactor for the same amperage. So we'll see. We'll see what happens between the two. Now, something else, two of the other tests that I mentioned were the following. Just for fun, I took the Xfactor used. So this is the Xfactor that was this. But this is after, I want to say 3 series races. One of them was a 6 race, another one was a 7, and the other one was either a 5 or 6 race series. So that's how many races this can has had. And like I said, this here, this is the used Xfactor with the used rotor, which used to be this new with the same rotor. So it's the same exact thing, or I should say the same exact motor and rotor combination. So we're looking at 50 and 51. They're close, but they're not exactly the same. So it won't be an exact comparison. The interesting thing is that after that 3 series, this motor dropped from 2,331 to 2,116 kVs. The other fascinating thing is, instead of pulling 5.7 amps, it's now pulling 4.9 for the same amount of timing, which is very interesting. And to me, I almost want to say that the older can is better, or the used can. And the only reason why I'm saying that is I was kind of slow when I was using this motor, and then I had to watch the timing and the temperature, but as it got older or more used, I was actually able to turn up the timing and not worry about temperature as much. Maybe I just got lucky, I have no idea. If any of you want to chime in, share some information, please go ahead. I'd love to hear your opinion, your input. Now, this is the used can with the new rotor. So I took the rotor out of the slot machine, which is the same number as this rotor. So it's the same, 12.3 silver rotor, which is the spec class rotor. And 52 degrees timing, again, not perfect, but it was just interesting to see this change in kV. And again, I don't have the rotor analyzer. I hope I get it soon. But once I get it, I'll have some timing comparison. But if we look at, let's see, that's 4 amps. This is 4 amps. When it was brand new, it was producing 2,092 kVs versus 1922 now. But that was at 48 degrees timing versus 52 degrees of timing now. So
there's less kV with the new rotor. So I'm curious. I mean, unfortunately, I can't compare the Gauss here anymore because, well, the rotor's used. But I can compare the Gauss of the old rotor and the new rotor once I get that analyzer. Now, slot machine. This slot machine, brand new, with its rotor, 50 degrees. This is the data right here. So all of them, I tried picking something close to 50. So I have 50 to 52. That's a bit of a spread. So it's not the best, to be honest, because once you start getting to that high timing, every degree makes a difference. But I'm looking at 3.4, so it's definitely drawing less amps than the other two, and it's 1944. The thing that I found fascinating, though, is that the analyzer read 51 degrees, and this is the slot machine with the old rotor. So I took the rotor off of the Xfactor, which is this one. Timing, this is the timing spread that I got, which I was surprised. All I did was change the rotor. But I'm now drawing 5.2 amps with that rotor. So I'm really curious what the strength difference is between the two. But as of now, like I said, comment below what's your opinion. I'll have a follow-up once I get that analyzer. But this slot machine rotor, I'm going to go ahead and take a gamble and install it in my VTA, and I'm going to run it for the next series. And we'll see how that goes, and then hopefully I'll have an update sometime in the future. Thank you very much for watching. I hope this was entertaining, mostly useful, to be honest, but if it's not useful, I hope it was entertaining. But again, thank you very much for watching. Please subscribe if you have not, and I'll catch you in the next one.
What? Oh, my hair! My tongue! My rod!